Hi everyone, welcome to our meetup. So I hope the audio and video quality is good. So let's wait for a few more minutes and we can get started. Oh, okay. Peter saying audio was a little bit quiet. Let me try to change my settings. How about now, Peter? Hi, Leo. Let me know if you want me to increase my volume a little bit. Okay, thanks, Tim. Cool. I changed my settings. Thanks, Peter. So I think this is our 150th meetup. We've been doing for nearly 3 to 4 years. Myself along with Tim and Annie. So you can see. Okay, I think it's 149. Maybe a little bit early. Cool. Thanks. Let's get started. Okay. So in today's session, it's like an introduction to deep learning. We will try to understand what's deep learning, and then we will try to cover three different ways to run our deep learning code. It could be Google Colab, Kaggle, and Vertex AI, which is from GCP. Yeah, thanks, Tim. It's 149. Yeah, cool. And then after completing these platforms, we will try to do one end-to-end deep learning using Fastai and Pytorch library. And then we will try to deploy the app using Gradio or Streamlit, and then we can share it on Hugging Face spaces. So where you can share your web app to others. So we can do that. Then we will try to understand the core of deep learning or any machine learning, which is stochastic gradient descent. So we will try to understand that. So for today's programming, we'll be using three different platforms. One is Google Colab, and then I'll use Kaggle, and then I'll be showing you a few other ways. One is Google Cloud using Vertex AI. Okay. So before doing any programming, let's try to understand a little bit on deep learning, and then we can try to understand more about the programming aspect of deep learning. So I'm going to write here. Give me a second. Yes. Okay. Cool. So you might be seeing lots of chatbots. Then if you are doing some online shopping like Amazon, you might be seeing lots of recommendations or voice assistants. Self-driving cars, and many more. So these are some of the examples of deep learning. But before going there, let's try to understand how deep learning evolved and what is the starting point, those kind of things. Let me quickly check this. Oh, cool. Okay. Let me share one more thing. Okay, cool. So this is one of the earliest invitation for artificial intelligence field. So in 1955, four people like uh, John McCarthy and then Shannon and Mincy and Rochester. So they were trying to set up a summer boot camp, like any workshop event, trying to answer these questions. Like they want to simulate how humans think. So they want to create a few other projects related to try to use computers to do whatever humans are trying to do. So their description is like if a machine can do a job, then an automatic calculator can be performed to simulate the machine. So it's one thing, automatic computers. Then how can a computer be programmed to use a language? Then neuron nets, which is neural network nowadays. So and which is also called deep learning. It's rebranded recently as deep learning. And then they were trying to do few other things like theory of size of the calculation, self-improvement, abstractions, randomness, and creativity. So this is one of the earliest uh, emergence of artificial intelligence field. So before starting artificial intelligence, also we'll be understanding artificial intelligence, machine learning, and deep learning. What's the difference? So in artificial intelligence, it's like anything you want to automate, maybe some intelligence, something like that. It could be rule based. In most of the, I think 1980s, we were mostly using rule based. For example, game of chess. So it's like mostly rule based. So I think it's also called the expert systems. So these are the things people were doing in 1980s. They were trying to create some large number of rules and then trying to solve a problem or tackle any challenge. So that's one thing. And then there is another subset of artificial intelligence, which is machine learning. So in machine learning, people were trying to solve things using data sets. So what do you mean by dataset is in normal programming, what we do is you have some set of rules, then you have a lot of data, then in normal program you write some lots of if else loops, those kind of things, and then you will get some answers. Maybe one of the example could be, let's say uh, the weather is 30-degree, and then let's say it's 4 p.m. Maybe one of the problem we are trying to tackle is ice cream sales. So we can write lots of if else, like if weather is greater than 30 and if it's less than 6 p.m, maybe the ice cream sales should be like 40 sales per hour. So we can create lots of rules. So this is like normal programming, but in machine learning, what we have is we just have data and we know the answers. Then our ML model, we call this as model. This ML model try to find some rules based on data and answers. So and then after few years, there is another field emerged. It's called deep learning. So in deep learning, it's called hierarchical representation. So what do you mean by hierarchical representation is Instead of in normal machine learning, we can call this as y equal to mx plus c. This is just only one calculation going on here, just a multiplication, matrix multiplication, and then you are trying to add some numbers. This is like a simple linear regression model. But in deep learning, what we do is we try to do the same thing with many layers. For example, let's say you have got some input data, and then you pass the input data to some matrix multiplications. Then you do some non-linear transformations. We will try to understand everything, but this is like high level view. We have many layers. Then finally, after doing lots of multiplications, we get the output. So learning means initially all these numbers in each layers, they are very random. We'll see in our programming, but let's try to understand big picture. So normally everything is like random number, but based on input and output, our model will try to change these numbers, and then at the end these numbers will be very much sense. So that's all about learning, but the name deep comes from number of layers in a network. So normally we have in ResNet, there are some better architectures to recognize images. One of the architecture is ResNet 50, 34, 101. So these numbers means number of layers. In ResNet 50, we have like 50 hidden layers. This is like layers. So that's where the name deep comes from. Okay, I think that's a good introduction to deep learning. But if we see the core of deep learning, there is an algorithm called stochastic gradient descent. So this is like a heart of deep learning. If you understand this, that's it. You can replicate the same thing for image, audio, video, NLP based in all the different varieties of data. The core is stochastic gradient descent. So today we will try to understand this stochastic gradient descent using some simple examples. But whatever we are learning, that scales well with large volume of data and different problems. Okay, so let's start some programming. We will start with Google Colab, and then I'll move to Kaggle and then Vertex AI. So what we are going to do is we are going to use some model. Maybe I'll show you some ResNet 50, ResNet 34, ResNet 101, these models, and we can see what each numbers in network mean. Okay, we'll try to input some image to this model, and then we'll try to get some results, and then we can interpret the results. Okay, so that's one thing. So before doing some programming, I'm going to introduce one more concept called pre-trained networks. Cool. So what does it mean is, in neural network, as I said before, initially these numbers will be random, but once you train the neural network, these numbers will be very meaningful in solving some particular challenge. So that's about pre-trained network. So in pre-trained network means someone already trained a neural network, and those weights and biases, they are not random. It already good at predicting something. Okay, so this is network. Initially these numbers in the network are very random, but if you train the network based on some data sets, then these numbers will be very meaningful, and we can use those model to make some predictions. So why should we do that is, so this one of the famous data set is ImageNet. This ImageNet dataset has more than 1 million, I think 3 million images, and then it has more than, I think, around 1,000 classes. So a lot of models were trained on this ImageNet dataset. We call that as pre-trained network, because let's say you got a challenge to predict uh, maybe bird versus animal. Let's say you are trying to install a camera and then you want to count how many birds are visiting your place, or is there any animals or nearby, so you want to count every day. So what you are going to do is you are going to build a neural network for this. So instead of starting random weights and bias, what we can do is we can use some pre-trained network, and then we can change those numbers a little bit based on our new datasets. This changing those weights a little bit, this is called fine tuning. So these concepts will be very much sense when we try to solve some problem, but uh, just I introduced two keywords. One is pre-trained network and another is fine tuning. Okay, I think with this knowledge we will try to solve some challenge. Let's get started. So for this I'm going to use Google Colab. So if this is your first session, what you can do is you can just Google about Google Colab and you can see a screen like this. This is completely free, and also they have some paid version for better GPU supports. So maybe let me introduce what is GPU. Sorry. So in machine learning and deep learning, what you are trying to do is you are doing lots of multiplications, especially tensor multiplication. I will explain what tensor mean. So when you are trying to do lots of multiplications, our CPU is specifically built to do lots of different work, like opening a web browser and editing a document, playing games, and there are so many things you can do with CPU. But GPU is specifically designed to do very few tasks. Maybe one is maybe games, for it's good for games, and then it's good for doing lots of multiplications. So this speeds up your entire training process. Let's say you have like 1 million images. To train 1 million images on CPU, let's say it takes like 10 to 12 hours. You can achieve the same thing on GPU in few hours, like 1 or 2 hours. I think the scale is even bigger, but I hope you get it. Cool. So let me explain what is tensor. So I'm sure you heard about the terms like TensorFlow, and this TensorFlow, and there is one more library called Pytorch. Even in Pytorch, there is lots of abstract. The classes like tensor. So tensor, the name tensor comes a lot in deep learning. So what does tensor mean is, let's say there is a number 5. This is like scalar, just a number with no directions, just a number. So this is scalar, and let's say you have a list 2, 3, 5. This is vector, and you know what is matrix. It has rows and columns. So this is matrix 2, 3, 5, 1, 4, 6, 3, 8, 9. So this is like a 2 dimension. So scalar no dimension, vector 1 dimension, and matrix 2 dimension. Anything greater than 2 dimension, we call that as tensor. Okay, anything greater than 2 dimension. For example, image. If you are taking some image, the image has 3 dimensions, or G, B. Okay, so red, green, blue, so that there are 3 dimensions in an image. And if you're processing text datasets, that's also greater than 3 dimension. And if you're doing lots of time series, that's greater than 3 dimensions. And video, audio, that's also greater than 3 dimensions. So anything greater than 2 dimension, we call that as tensor. In deep learning, we mainly use deep learning for solving problems like time series, image recognition, audio or video classifications, those kind of things. So we deal lots of tensor datasets. So that's where the name TensorFlow or tensor comes from. So let me quickly check this. Thanks, Leo. I think in Jupyter Notebook, we can also paste these things. You can get results. Cool. Okay. So if this is your first session to Google Colab, you can Google Colab and you can see a screen like this. Then what you can do is click runtime. Then you can change runtime type. And then you can choose GPU. And then if you have some paid version, you can choose high RAM. Cool. This is my setup. Once that's done, I can click connect. And what's happening here is it's trying to create a server for me on Google's servers. Okay, I think it's connected. To see what GPU they have allocated me, what I can do is just type NVIDIA, exclamation mark, NVIDIA SMI. So whatever I do with terminal commands, I can run terminal commands in Google Colab or any Jupyter Notebook using exclamation mark. For example, let's say ls. It's going to list all the files and folders in this directory. So there is only one folder called sample data. And you can see it here. If you click this folder, you can see all the files. Also, you can upload things. To upload things, just right click upload, and you can upload these things. I'm going to upload 3 images. Okay, cool. So we have started a Jupyter Notebook, and then we have uploaded some images. Now what we can do is maybe let me quickly give you some outline what we are trying to do, and then we can do that so that you can understand the big picture and minute details. So first of all, we are going to load corresponding libraries. Then we can load a pre-trained network. So this pre-trained network already learned something because it's trained on ImageNet datasets. So those weights and biases are not random. They are good at predicting something. So what we can do is we can input some image to the model, and then we can do some testings. Okay. So this helps you to understand what is pre-trained network. Okay. So this is first part. So in part 2, what we do is we load a pre-trained network, and then we do some training. Okay, load a new pre-trained network, and maybe we create our own data sets, and then we will do some neural network or deep learning training so that we can know how those weights and bias are changing. So this is called fine tuning. Okay. So in part 1, we will be doing only pre-trained network predictions, but in part 2, we will be doing pre-trained as well as fine tuning. Okay. And then we can try to deploy things. so that you can share a link with others. So these are the things we can do. If time permits, we can also try to understand stochastic gradient descent. Okay, that's the goal. Cool. Okay, to do this, what I'm going to do is I'm going to import models from Torch Vision library. So to run some cells, this is called cell. To create many cell, just move your mouse over here, like in the center. You can see code and text. If you click code many times, it will create code cell. And let's say you want to type something. It's like a documentation. You can click text, and then you can import libraries. You can type anything. Okay. So I have imported models. To see what are the models in this models module, we can see using dir command function. So it's going to display all the important, I think all the models inside the Torch Vision library. So there are so many models. So for maybe in today's session, we can use ResNet model equal to models dot, let's see, ResNet. Just type res and wait, and it's showing few things. Maybe we can use ResNet 34. Okay, so if I run this, it's going to give me a model, but those weights are random. Okay, to see the weights and biases, you can run model.parameters. So it has given me some weights and biases. It's completely random, but what we need is we need some meaningful weights and biases that's trained on some other ImageNet or other datasets. For that, what we can do is we can set pre-trained equal to true. Okay, so when you do pre-trained equal to do, it's downloading those weights and biases. So now if you let me run this. So now if you run list model.parameters, those weights and biases are trained from ImageNet library, ImageNet datasets, which has more than 1 million data and 1,000 different classes. Okay. So now what we can do is we can input some image to this model and see what is telling. Okay. So we can do that. So we are going to make some prediction. To make some prediction, what you need to do is you need to do model.eval. Okay. So it's doing some internals like batch normalization and dropouts. So there are some minute changing. So that differs from training and inference. So now we are focusing on inference. So we need to tell the model we are doing some evaluations, not training. Okay. Now we can input the image and then we can see some results. So what I'm going to do is I'm going to use Python image library. Oh, sorry, from will import image. So let's open an image.open, and I think I already imported a few images. Okay, I imported 3 images. Let's use tiger.jpg. Okay, so we have got a model. Let's print this image. So this is the image. let's try to pass this image to the model and see what happens. You cannot actually, machine learning and deep learning, it handles only numbers. It does not know how to handle image directly. Maybe let's try to pass this. It's going to throw some error. Let's see okay. So what it says is, did not match, some of the arguments have invalid types. So ours is JPEG image file, but they need everything numbers. Now let's try to convert this image to numbers. Okay, let's try to do that. So this Torch Vision library also provides some transformations. So that transformation functions takes some image and then it converts to numbers. So we can do that. So we are going to do a few transformations. One is we can resize all the image to a same size. Then we can convert all those image. After resizing, we can convert everything to numbers. So to convert everything to numbers, we can use tensors. Okay, transforms to tensor. Okay, we have done two things, and one more thing is this ImageNet. So we are using pre-trained network, so we need to use some weights. I think some transformations that's done by ImageNet. We need to use same thing. Maybe let me quickly explain this so that could be a little bit clear. So normally in machine learning or deep learning, we do normalization. Let's say you have got 3 columns. One is age, maybe another is salary, and let's say we have got 2 data, age and salary, and you're trying to write something. Cool. So age should be like it's like maybe 1 to 100, and salary, let's say 10,000 to 30,000, 10k to 30k. And let's say you're trying to do some algorithm on this data set. So what's the problem here is, one column is in different scale and another column is in different scale. So what you do is you normalize this data. What does it mean is, let's say you are doing some min max scaling. What you do is you convert everything to 0 to 1 range. Okay, so here the minimum is 1 and maximum is 100. You take 1 as 0, 100 as 1, and then you equally distribute. So everything is 0 to 1 range. Also here everything is 0 to 1 range. Let's say I have got some new data. Let's say the age is 24 and salary is 12,000. Also assume I have already trained a neural net or any model using this dataset. Now I'm going to make a prediction using the new test data. Okay, so here the age is 24 and maybe the salary is 12,000. I cannot directly pass this data to the model. Okay, I cannot directly pass this data to the model. What happens is, it's in different scale. One is 24, but our model is trained everything 0 to 1, and here the salary is 12,000, but our model trained on 0 to 1 range. So what we need to do is we need to convert this to 0 to 1 range, 0 to 1 range. To convert this to 0 to 1 range, I need to know what is the minimum and maximum in age, and what is minimum and maximum in salary, so that I can convert these numbers to 0 to 1 range, and then I can pass this to my model. Okay, so we need to know some numbers, what is minimum and maximum. So this is called min-max scaling, And another way of scaling is normalization. In normalization, what you do is you scale like this. You any number divided by average of the data, and then I mean the column, and then you divide by standard deviation. So we need two numbers here. One is what is the mean of the data, and what is the standard deviation of the data. Okay. So if you know what is the mean of age and what is the standard deviation of age, as well as what is the mean and standard deviation of the salary, you can solve this problem. But what we are doing is we are using ImageNet, so we need to know ImageNet's mean and standard deviations. So let me Google this. So this is the mean and standard deviations. So if you see Pytorch model, all the pre-trained models expect input images normalized in the same way. So 3 batch RGB, and then it should be scaled to this range, mean and standard deviations. So this is like ImageNet's average, mean and standard deviation. Okay. So let's use this. Or let me copy from Stack Overflow. Okay. I think it's not clicking. Okay. So we are going to normalize the data. Transforms dot normalize, and then we can paste mean and standard deviations, comma standard deviations. Okay. Let's run this. Oh, I already have these things. Cool. Typo transforms. Okay, so we have created a function pre-process. So this is a function. You can pass any image to this function and it will do all these things. It resizes the image and then it converts everything to number and then it normalizes the data. So let's try to do that. Image to tensor equal to pre-process of, you can pass any image. Now let's print this image to tensor. So it should be numbers from 0 to 1 range, these things. Okay, so now everything is 0 to 1 range. Okay, now we need to do one more thing. In deep learning, we don't train images one by one. What we do is we always put a lot of image together. This is called batch training. So instead of training one by one, we pass like 64 image or 512 images like this. We put many image as a batch. So these models expect everything in batch. So we need to add one more column. Okay, I think one more initial axis. Let's do that. Convert to batch. So we will be learning all these functions in the upcoming sessions, but now the main goal is understanding pre-trained. Then we are adding a new axis. Okay. So now let's put this to model. Predictions equal to model of batch transformations. Cool. Okay. So let's print predictions. It's going to give us 1,000 different classes, 1,000 different numbers. Okay, let's try to find the max. So the maximum is 10.44. So now let's try to find what is the position of this value, okay, or max. It says 292. Okay, so our model's prediction is 292. Now let's try to find what those 1,000 classes in ImageNet. If you find that, then we can understand. Okay, here it says 292 is tiger, so ours is correct. And you can see what are the things we used in ImageNet. Okay, this is 1,000 classes list. It has lots of animals and so many things. Let's quickly check. Okay, let me share. Okay. So now what we can do is we can move to another platform, Kaggle, and then I'll show you how to run things there, and then we can try to understand our part 2. Part 2 is understanding pre-trained plus fine-tuning. So fine-tuning means, as I said before, you can see here. Fine-tuning means you load a pre-trained network and then you use any dataset to change those weights and biases a little bit based on the new dataset. So that's called fine-tuning. We can do that. And before that, let me talk about this. So recently there was a course happened in EQ, Practical Deep Learning for Coders. I was one of the teaching assistant for that course. I think this course will be publicly available very soon. I'll let you know once it's done. Maybe once it's publicly available, we can go through those sessions one by one. But for now, I'm going to share some of the notebook that Jeremy used in his teachings. So this is one of the notebook. Is it bird or is it bad? Creating a model from your own data. So what we are going to do is we can run this. Here what he has done is he load our own data sets, and then he used a pre-trained network, and then he fine-tunes based on our new data sets. So we can replicate the same on maybe Google Colab so that we can also do some demo or deployments. Okay, so if you see some notebook like this, you can click copy and edit. If you click copy and edit, for me it's showing edit my copy because I have already clicked this. But if you are checking this for the first time, it will show you copy and edit. Just click this and it will open a virtual space for you. Okay, it has created a GPU based machine for me. Let's run this. So you can, it's very similar to Google Colab. You can shift enter and you can run everything. And let's say you have your own data sets. You can also add data here. You can create data sets and then you can do some deep learning training here. It's free. I think they are giving us like 40 hours per week. That's good. and you can also see GPU RAM usage here. So I haven't utilized any GPU. They have provided us 16 GB GPU, which is good. Okay. So what I'm going to do is I'm going to copy paste these things, and then we can run everything on Google Colab. So we need to install Fastai library. I'll show you. Let's run this. To run anything like this, you can use exclamation mark, so that whatever you are doing with terminal, you can do the same thing with Jupyter Notebook. Okay. Once it's done, we need to restart our Google Colab. Oh, it's not. Okay, let's try without restarting and see what happens. Okay. So here, okay, it's working. So we will be understanding all these things in our upcoming sessions, but now let's focus on only the fine tuning part of this. So we downloaded an image from internet, and then we are seeing that here it's bird. Now let's try to do classification. So what we are trying to do is we are going to download some 200 bird image and 200 forest image, and then we can train a neural network to predict whether that's bird or not. Let's do that. Okay. So while downloading things from internet, sometimes those links are not real image. It might be broken. We can see those things in failed function. So far what we have done here is we are creating two folder, forest and bird, and then we are putting 200 images in each, and you can see those things here. We have created bird and forest. Bird has some image and forest also has some image, and we are going to train a neural network. To train a neural network, we are not going to start everything from scratch. We will be using a we are going to use some pre-trained network, and then we can fine tune the network based on our new data sets. Okay, so this is our some of the sample training data. We have got more both forest and bird, and you can see it here. Okay, so here Jeremy used ResNet 18. Let's use the same. And you can see the name fine tune. So what does it mean is we are loaded a model, and then we are fine tuning the network, meaning we are changing those weights and biases for our task in hand, which is predicting forest versus bird. So once this is done, you can see the train loss, valid loss, and error rate. So this error rate means if there is any mistake in prediction, there is no mistake in the prediction. So we can see it here. So in the upcoming sessions, we will understand what is loss mean, what is error rate, those things. But now let's focus on running everything from top to bottom. You can replicate the same thing on Kaggle, Google Colab, and I will quickly show you one more platform. Cool. Now we have done a training. Okay. Now let's use our own image and see what are we getting. Okay, so I think we showed bird.jpg. It says our model says it's bird with 100% probability, so that's good. Okay, so now what we can do is we created a model. Let's quickly show you how to convert this to a demo. For this, that link is restricted, needs to be okay. Let me quickly do that. Oh, okay. Anyone with the link. Cool. Okay. Done. Maybe try now, Tim. It should work. Okay. So we have trained a model. Now what we need to do is we need to put that model into production or any web app so we can share with others. For now, let's export the model. To export the model, just type learn.export. So if you do that, it's going to create a pickle file, and you can see it here, export.pickle. So this pickle file has all the information about the model, and you can load this export.pickle file, and you can put any image to this, and then you will get some results like bird or not. So we have exported everything. Also, we need to know what are our labels. Our labels are stored in learn.dls.vocab. Okay. So it has bird versus forest. Okay. So now what we can do is we can save this labels equal to learn dot vocab. Okay. Now write a predict function. So this predict function takes an image, and then it converts the image to PAL image, and then create. Okay. Then we can make a prediction. Once you make some prediction, you will get three things. One is prediction and prediction's position, which is argmax, and then you will get the probability props. Okay. Now let's return a few things. For each label, we are trying to find the probability. Okay. Cool. We have written some prediction function. Maybe okay. Let's install one more library called Gradio. So Gradio is a library where you can quickly use any model deployments. So build and share delightful machine learning apps. So this is one thing, Gradio, and then another is Streamlit. So this is also a fast way to convert your model to or any Python web app, Python things to a web app. And there is one more thing called Hugging Face Spaces. So in Hugging Face Spaces, you can share your Gradio or Streamlit app with others. and it's permanent storage, and it's free, and also they have some paid plans. Cool. So for this session we'll be using Gradio as it's simple to use. Okay, so we have installed Gradio. Now let's quickly open Gradio from import Gradio as gr. Okay, so now we can create a simple web app, gr.interface. We need to use our predict function. I think you can see the arguments fn, which is our prediction function, and we need to pass the input image, and we need to inform what is our inputs and what are the outputs and how many outputs. Okay, let's do that. So fn is our prediction function, and inputs okay. So we have provided some input. Our input is gr.inputs image, and we are mentioning its shapes equal to. Okay, now let's mention about outputs. Maybe let's enter a line. Okay, outputs equal to gr.outputs, and our outputs are label. So input is image and output is label, so that you can use gr.inputs and gr.outputs label, and we can mention a number of top classes. In ours it says number of top classes. In ours it's 2 class. One is forest and another is I think forest and bird. Okay, so num top classes 2. Then launch the app, then share it. Okay, shape. Okay, it's creating an app. Okay, it's done, and you can open this app, you can share with others. So this is the app we just developed. So you can upload any image. Let's input this image, submit. It says it's bird with 100% probability, so that's good. So also you can do some advanced things with the Gradio. So this is very simple. Maybe in the next session we will try to understand more about Gradio and how to customize things. Also you can use this as REST API. So you can see the API. So if you have got some front-end experience, you can use this in any HTML based or any apps. You can use that. Thanks, Tim. Okay, so we covered a few things. Now let's say one more thing I would like to cover is both Kaggle and Google Colab, they provide a free GPU. But let's say you are working with some large volume of data and you want to use some new GPUs like 800 GPUs. In those cases, you can use something like Google Vertex AI. Let me open that. Okay, so it's here. I created a demo project, and you can type Vertex AI. So this is Google Cloud. Just go to Google Cloud and then create an account. They provide you $300 credit, and you can use those $300 credit to train some models. So click enable Vertex AI API. So it's creating. Okay, so now what I can do is I can move my mouse and you can see there are so many things. So this Vertex AI is like a end-to-end training and deployment pipeline provided by GCP, Google Cloud. So what we need is Workbench. Just go to Workbench. Click Enable. And you can see some pricing. CPU is Australian 0.007 per hour. GPU is like 36 cents. GPU standard is like 5 cents. It might take 1 minute. Okay, I think it's done. Once that's enabled, you can click Workbench. Maybe it's still running in the background. Okay, I think it's done. Cool. So once you click Workbench, you can see Manage Notebooks and User Managed Notebooks. So Managed Notebook is completely managed by Google, and User Managed, it's managed by us, which means we can install our own things, and it's very customizable. Let's create a User Managed Notebook. So create notebook. Here you can use any name and you can choose your own locations. Some of the modern GPUs, they are available only very few regions, US West one, and this one is good. So here they provide lots of GPUs, powerful GPUs, and you can choose your own operating system. I think they provide Debian 10 and Ubuntu, and then you can choose the environment. So let me choose Pytorch 1.1. It also includes Fastai and other things. Then you can choose your machine type. Okay, here's the thing. You can choose any standard machine. Let's say I want like 60 GB RAM, 16 CPUs. I can click this, and this is like roughly around 60 cents. And then I can click my GPU. I can choose these GPUs. K80 is like a basic one, and V100 is one of the powerful. It's a bit expensive. If you click this, and then you can install GPU drivers. So this is one thing. Let me show you some of the recent GPUs. They are in A2 high GPU. Click this A2 high GPU, and then you can click whether you need 85 GB RAM or 170 GB RAM, those things. Let's click this, and you can choose number of GPUs. I just need one. I think okay, if you choose like 8, this one, and then you can choose 8 GPUs. It's very expensive. I think they don't provide estimate. It's very expensive one. And then once this is done, you can click disk. You can choose your own sizes. You no need to change anything in networking and permissions. You no need to do any changes. Security, no need to do anything. Then you can click create. Maybe before creating, let me change this to basic one. basic GPU and install. Okay, it's going to cost me like 50 cents per hour. Then click create. It might take around 1 minute. Okay, I think I need to change my GPU settings, but this is the process. You can play with it. So once this is done, if you click open Jupyter Lab, you will see a screen that's very similar to Jupyter Notebook, and you can start writing program there. So that's another way to write deep learning code. I think in today's session we covered quite a few things. One is introduction to deep learning, and we learned about 3 different platforms: Google Colab, Kaggle, and Vertex AI. Then we did a end-to-end deep learning. In end-to-end deep learning, we did 2 parts. Part 1 is understanding pre-trained network, and then part 2 is understanding pre-trained network as well as fine-tuning. So then what we did, we try to deploy things in Gradio app. Maybe in the next session we can understand more about how these learning happens. Okay, especially when you click fine tune. So let me show you here. Okay, especially when you run this, it's going to do some model training. I think I need to rerun everything from top to bottom, but if you run this, it's going to learn something. Okay, let me see where I can show here. Yes. Okay, so when you do learn.fine tune, it's going to use stochastic gradient descent algorithm, and then it's going to learn something. Okay, so initially after one training, the error is like 22%. After few 3 epoch, I will explain all these terminologies in the next session, but after few training, the error is close to 0. There is no error in the model. So we will try to understand how this happened. Okay, so the core is stochastic gradient descent. We can see in the next session. I hope today's session is good. Thanks everyone. See you next week. Bye.